Today, we will talk about the central limit theorem, CLT, and its key characteristics. In probability theory, the central limit theorem states that the distribution of a sample variable approximates a normal distribution as the sample size gets larger, assuming the samples are of identical size and regardless of the population's actual distribution shape. This means that the mean of all sampled variables from the same population will be approximately equal to the mean of the whole population, and these samples will approximate a normal distribution, with their variances being approximately equal to the variance of the population as the sample size gets larger. According to the central limit theorem, the mean of a sample of data will be closer to the mean of the overall population as the sample size increases, regardless of the actual distribution of the data. Sample sizes of around 30 to 50 are usually sufficient for the CLT to hold, meaning that the distribution of the sample means is fairly normally distributed. The central limit theorem revolves around samples, sample sizes, and the population of data. It is often used in conjunction with the law of large numbers, which states that the average of the sample means and standard deviations will come closer to equaling the population mean and standard deviation as the sample size grows. The central limit theorem is useful when examining the returns of an individual stock or broader indices in finance. For example, an investor may study a random sample of stocks to cultivate estimated returns of the total index, ensuring a sufficient number of randomly selected stocks are sampled for the central limit theorem to hold. The central limit theorem is useful when analyzing large data sets because it allows one to assume that the sampling distribution of the mean will be normally distributed in most cases, allowing for easier statistical analysis and inference. Investors can use it to aggregate individual security performance data and generate distributions that represent a larger population distribution for security returns over a period of time. A sample size of 30 is common because it often increases the confidence interval of population data enough to warrant assertions against findings. The central limit theorem doesn't have its own formula, but it relies on sample mean and standard deviation to distribute the data across a probability distribution curve. Here are 5 key takeaways. 1. The central limit theorem, CLT, states that the distribution of sample means approximates a normal distribution as the sample size gets larger, regardless of the population's distribution. 2. Sample sizes equal to or greater than 30 are often considered sufficient for the CLT to hold. 3. A key aspect of CLT is that the average of the sample means and standard deviations will equal the population mean and standard deviation. 4. A sufficiently large sample size can predict the characteristics of a population more accurately. 5. CLT is useful in finance when analyzing a large collection of securities to estimate portfolio distributions and traits for returns, risk, and correlation. Hope this would help. Thanks for watching.